Chapter 11, Section 4, Volume of Pyramids and Cylinders. Volume is defined as the space that a figure occupies. It's measured in cubic units because it's three-dimensional, written like this, or cubic centimeters here. The volume V of a cube is the cube of the length of its edge. So since they're all the same, it's basically length times width times height, but they're all the same measure, so it's just the length of the edge cubed. Cavalieri's principle states that if two space figures have the same height and the same cross-sectional area at every level, then they have the same volume. So this is kind of comparing our right prisms or right figures, whatever they may be, with our oblique ones. So the area of each shaded cross-section below is 6 centimeters squared. So all of these have the same cross-sectional area at every point. Since the prisms have the same height, their volumes must be the same. So basically, if I take this and I kick it sideways, since they have the same height and since they'll still have the same cross-sectional area at every level, so even if I raise this plane up, they'll still all have the same cross-sectional area. All of these figures will have the same volume. You can find the volume of a right prism by multiplying the area of the base times the height. So if we have a rectangular prism, length times width times height. If we have a triangular prism, 1/2 base times height of the triangle times the height of the prism. We'll see that in our problems. So here we have our first example, and it's a rectangular prism, and we're looking for the volume. The volume of any figure of any prism is the area of the base times the height. So in this case, we have a rectangular prism, so the bases are rectangles. So we find the area of the base, 24 times 20 gives us 480, times the height gives us 10. Our final answer would be 4,800 centimeters cubed, and it has to be cubic units because we're talking about volume. Now if we look at our next example, looking at a cylinder, the volume of a cylinder is the product of the area of the base and the height of the cylinder. So still area of the base times height, but in this case the base is a circle, so pi r squared times the height. Now, even if it's oblique, this is still the formula. So the area of our base here, well, our diameter is 2 meters, which means our radius is 1 meter. So it's going to be pi times 1 squared, and our height is 3. So this, in terms of pi, is going to be 3 pi meters cubed for the volume. A composite space figure we've worked with in the past sections is a three-dimensional figure that is the combination of two or more simpler figures. We can find the volume of a composite space figure by adding the volumes of the figures that are combined. Volume tends to be easier than surface area because here we don't have to worry about what sides are being cut off. All we have to worry about is the fact that this is half of a cylinder and this is a rectangular prism. So we want to find the volume of the rectangular prism, which is going to be 24 times 12 times 10, length times width times height, which is going to give us 2,880 inches cubed. That's for the volume of the prism. Now for the cylinder, we have half of a cylinder. Well, the volume of a cylinder is going to be the area of the base, so pi r squared, times the height. But in this case, it's half of a cylinder, so we're going to take half of that. We get that the volume is, well, if this is 12 inches, then the radius is going to have to be 6, because that means the diameter is 12. So it's going to be pi times 6 squared, which is 36, so 36 times pi, times the height of the cylinder, which is this measure here, which we know must be 10, all divided by 2. So we get 360 pi divided by 2, which is going to give us 180 pi inches cubed. To find the total volume, we take our 2,880 cubic inches, we add it to our 180 pi cubic inches, and we label our final answer. We can't simplify this any further unless we were to evaluate this, but then we'd have to round our final answer.